Welcome back to Better Through Tech. Today we're going to be looking at LEDs, how to wire them up, and the code that commands them. Let's jump right into it. As you can tell, we already have our Arduino IDE up and running. This is the standard layout, as you see. It didn't always used to be like this, so just in case you're wondering, if you ever delete this to clear it and start over again, just be aware that that void setup and that void loop has to be there. It doesn't necessarily have to be a void, but for purposes for right now, until we start getting further into the classes, it's best that we leave a void there. So I'm going to say for right now, it's probably best that you leave the voids there, because we're not returning any information back to any function or the main program. So we'll just leave those voids there. Got to have them in order to make the system work, of course. So, anywho, let's get to our programming here. We're going to enter down a little bit, and we're going to go to the very top. This is the space that libraries will either get submitted or entered into, which we won't be doing that quite yet. And this is also where you're going to enter your variables. And this is also known as the global area. So anything up here can be seen globally. The entire program can see that information. So if you store any variables that aren't attached to pins, any kind of holding values that are put up there will hold on to that information and can be seen by other parts of the program that are further down the line. So we're going to enter in an int, an integer, and we're going to give it the name of LED, because we're messing with LEDs today, right? And it's going to equal, for us, or for you, pin 2. You can pick any pin you want, as long as it's between 2 and 13. Don't use 1 and 0 for right now. I think it's 1 and 0. I'll have to get back to you on that. I'm pretty sure it's 1 and 0. Don't use those pins for right now, because those are the pins that are used for the Arduino to communicate with the computer. And if you try to hook something up to it, it'll cause it to error out. There's ways to get around it. And again, we'll get into that later. But for right now, just use pins between 2 and 13. Any of them are fine. Even ones with the little tilde. That's pulse width modulation. That's for dimming purposes. It's something that's really fun to play with. But again, we might be getting into that a little later in this episode. If not, probably more than likely the next episode. But now that we got our name down, we're going to go into the void setup area. And the most common practice, as you're getting started, you don't really necessarily need to do this, but it's a good idea to do it. It's the most common practice for coding is when something's within brackets, like these curly brackets, you always want them tabbed in. Additional tabs will need to be used if you're using an if else, a for loop, a while, or anything along those lines that have their own bracketed system to them. Additional tabs will be needed, but since we're only dealing with the base setup, the common way to do it right now will be just one tab in. It's, like I said, common practice. It's for it helps keep track of what parts of the code are attached to what section that's looping, essentially. Anywho, we're going to go into camel casing. We're going to call this pin mode. Camel casing with a capital M, no spacing. We're going to use our curved brackets. We're going to call that an LED name again, and we're going to go all caps, output, right? Because we're going to tell it that when it's operating, it's going to send the signal out. Next, we are going to go down to loop. And this is where the main part, or the most amount of fun we're going to be having today, is going to be spent. So the first code that we're going to be going over is digital write. It's a camel casing word, digital, right? With a capital W, digital write. Make sure to have your curved brackets in there, or it will not change colors. That is very important, and so is the camel casing. It will still light up orange if you don't have a capital W in there, but it will flag it as an error. So make sure you get that camel casing in there correctly. And again, we're going to call our LED variable, right? And now we're going to say hi, all caps. And in the programming world, especially with microcontrollers, or Arduino specifically, hi means on. In this case, it'll be 100% on. There are 255 steps in between for dimming purposes for the Arduino Uno. The other controllers, like the MKR, the ESP32, the Mega, all those have, or actually the revision 4, the Minima and the Wi-Fi actually have significantly more. We'll go into the math about how that works and why it works the way that it is, and we'll show you how to take advantage of it later. But for right now, we're only going to deal with ons and offs. We are going to have some fun blinking some LEDs. Now we're going to give it a delay, so it knows how long to keep that light on. So 500 milliseconds is what we're going to be looking into. That's half of a second. And again, then we're going to do this again. We're going to go digital right. Right, and then we're going to call that LED again, and we're going to say low this time. That's going to turn the LED off, followed by another 500 milliseconds. This will now keep the LED off for half of a second. And now, since we're in our loop, that will keep on playing over and over again. It'll stay on for half of a second and then turn off for half of a second. And then I'll keep on doing that over and over and over again. Another way to look at this, if you have trouble keeping track of this, is you can actually, for readability's sake, you can actually make this significantly easier on you. I like to do this times when I get into bigger codes, because it just makes it so much easier to follow. You can actually give words meaning, and give them like a high-low value. So on could be high and off could be low. So instead of actually saying high here, you can actually just say on. And low, can replace that with off. Does exactly the same thing. Just makes it a lot easier to read. So if you're having a hard time keeping track of anything, or if you're getting into bigger codes like I like to do sometimes, it's easier just to have it on there. So at a quick glance, if you're trying to find something or trying to debug, it's really easy to find. So next, we're going to jump over to Tinkercad. Oh, hey, let me finish that up real quick there. Output's not going to work too well if it doesn't have the T. You know. Anywho, okay, now let's get back on track here. Let's go to Tinkercad. Let's pull up our setup here and what we're going to be going over. I'm going to start off with this one right here. This is known as a breadboard. If you don't know already, this is where all of your work is going to take place while you're prototyping your stuff. If you want to work on your buttons, potentiometers, LEDs, screens, like LCDs or OLEDs, there's lots and lots and lots of things you can connect to these. If they're not hooked up through a shield, which I will touch upon a little later, everything is going to be done on this. And as you can tell as I'm highlighting these, through A through J is going to work from left to right. So if you plug something like an LED in per se here and here, everything along that track will be active through that LED. So you could put an LED leg here and an LED leg here, and then down here you can connect this to the negative, which now you can see that now that I've highlighted the power rails, they go from top to bottom. So that's just one good thing to remember. Yes, there is a split right down the middle, so you can hook up circuit boards onto this, so that way the teeth on one side will be on one side, and the teeth on the other will obviously be on the other. So that is a quick 101 on how the breadboards work. Now let's pull up over here onto our Arduino. This is how we're going to set this up. And as you remember, we used pin 2 on the Arduino IDE to signify what pin we're going to be using. So we have it here on pin 2. And we have that pulled down and around onto the anode side. Now, if you don't know what the anode and cathode is positive, cathode is negative. And I will, once I get the Arduino, I got a camera set up here so we can actually see my setup. I'll show you the LED that I'll be using, and I'll show you how to identify these. On here, it's relatively simple because it tells you anode and cathode, but this LED has a flat side to it. So all LEDs have a flat side to it. That will signify the negative or cathode side. And if the legs have not been cut, it will be the shorter of the two legs. And if it's a positive or an anode, it will be the longer of the two legs. So they give you two different ways to identify them. So if the legs have been cut, just look for the flat side of the LED. Once you grab a hold of it and look around, you can see it. It's not too horribly difficult. And I have a clear LED in my hands. I will try to do my best to record this. I know it might not come across the camera too well, but moving on with that. So we're going to connect the pin 2 to the anode side of the LED. Remember, these work in like I have it set up from top to bottom because we have it on the side now, but it'll connect to the anode. Now the cathode side, we're going to connect a resistor to this. Now resistors, glorious little things. There's two different ways. There's two things you need to know when you're using a resistor. The gold band is not hugely important unless you get into like super specific stuff. The gold band, I do believe, is 10 to 15% tolerance. Give me 1 second. I'm going to look it up. So the gold band on a resistor. So I'm pretty sure that the gold band stands for like 10 to 15% tolerance. That's how much leeway it has in between. So, okay, it's 5%. The gold band is 5%. Silver is 10%. So the different colors, and that's not hugely important, especially for like general projects. If you want to get into like uber specific stuff that's super sensitive, then you want stuff that's very on point. And so that band will probably turn red. But for the most part, and a lot of the projects we're doing now, you're not ever going to have to worry about that. And most general use resistors are going to have a gold band anyways. The things that you really need to pay attention to is the size of the resistor. The size of the resistor dictates how much power it can handle. And I have two examples I'll show when I get my feed going for the Arduino. I have a 8 watt resistor and a 1/4 watt resistor. So so the size dictates the amount of power it can handle. So the bigger it is, the more that you can work with. You have ones that can go up to 1/2 watt, 1 watt, 5 watt. I mean, they start getting really big. Also, the color banding. So on this one, you can see it's a brown, black, brown. That represents 100 ohms. So the color orientation really, the color orientation will tell you how big the resistance capacitance, or I shouldn't say capacitance. This is not a capacitor. It'll tell you how much resistance the resistor is working with, and in our case, this is going to be 100 ohms. So now that we're done with that, let's get get my camera turned on here, and we will go over some stuff on the camera. Got it turned on. So here's the LED that we're going to use for this example. Let me get this in focus here real quick. This is a 10 millimeter. You notice this is quite large compared to most. They will come in other through-hole mounted styles, like they look a lot like this. This one's clear. Some of them do come frosted to help disperse the light a little more. They do come in 5mm, which is a very popular size, and they also come in a 3mm package. Everything else will come in the range of probably surface mounted, which a lot of professional level electronics will usually deal with. If you're pretty handy, consumer level or personal projects, you can get them on there too. I've done it. And maybe we'll save that for a different class, for a different mini-series. But for right now, we're just going to focus on through-hole mounted LEDs, just like this one. And like I had mentioned just a second ago, if you look, you can see the different length of the legs. The legs, like I had said, is what signifies a positive and negative. The longer leg here is the anode, which is the positive side. And then on the short leg here, this is the cathode, or the negative. And that's how you're going to figure it out. Well, if the legs have been cut and they're both exactly the same length, if you look on here, there's the flat side right here. And I'm probably not going to be able to show this on the camera, but if you have your own set of LEDs, you can look at this and you'll see. There is a flat side here that will signify the cathode or negative side of the LED. Okay, so I'll get that out of the way. Here is two examples of the resistors I got. that we'll most likely end up using for this. We're not going to focus in on the colors. Just wanted to show you the size. This little itty bitty little guy right here is the 1/8 watt resistor. We will use stuff like this a lot for or I use them a lot for buttons or potentiometers, as they don't. Well, the way we are going to be using the potentiometers, there's not going to be a lot of electricity flowing through them, so you don't really have to have a large resistor to handle the heat dissipation. This one right here is a 1/4 watt. This is what we're probably more than likely going to end up using for most of the lights, because they will carry a little more electricity through them, so thus they'll conduct a little more heat. And as you can tell, this one right here actually is the black brown, if that's coming in on the camera. This is the resistor we're going to use through the Tinkercad, and this is what's going to be on our build here. So let me slide those out of the way, and I will pull this into view. And per how Tinkercad is set up, this is exactly how I have it set up. The ground goes into the ground rail, and the resistor is plugged in to that ground rail. I don't know how well I don't know how well it's going to come in there, but then we have the wire plugged into pin number 2, and that's going just right next to that resistor. They're not on the same track. Don't put them on the same track. You're not going to have good results if that happens. They're going to be placed on 2 different rows right next to each other, and we're going to grab that LED with those 2 different length legs, and we're going to put the short leg in line with the resistor and the long leg in line with the wire. And then once you get it in there, it'll look something like that. And now you are ready to run your very first code. So now let's jump back over to the Arduino and pull up the IDE again, and we will now plug in our Arduino. And I ran a test run here, so it's going to start blinking. But now, if you look back up on the screen, you can hit your down box here, and it will say Arduino Uno. Mine says COM4. Yours is going to say something else. Click on that, and just like the last video, it will confirm that it has been connected. Now, what you can do is hit upload, and now it will upload your code. You know, the verbose will come across and start uploading, and then when it says Xavier, dude, done, thank you, you are off and running. There is your blink. As you can tell, the pace of the blinking has changed, so it has received the command, which is some awesome stuff, and there is your very first blink code. Well done. So let's start playing with it, and let's start doing some cool stuff with it. So, a lot of code deals with functions. I hugely believe that even through the project level and personal level, I believe that functions need to be set up on here. It makes code significantly easier to use and significantly easier to read. Well, depending on the section and how much code you have in it. But I wanted to start you off early, and I want you to see and understand how it works. There are people out there in the world of YouTube that do this. They do go over it. They show you how to do it. I feel like there's not enough of us out there, and that's one of the reasons why I want to show you it. There also is books out there that do it, but yeah, I feel like sometimes they don't really discuss the advantages of how it works. So, when you are doing a function, we are moving a brunt of the code into a different section. So in this case, we're going to call it void, because we're not returning any function back to the main loop. So when you're not returning code, so let's say I had this all programmed out, if we had to return a function back up to this, you're going to use something like these. So if we're going to return an integer, you would use an int here. You would use an int instead if you were returning information. We are not doing any of that right now, so we are just going to set up as a normal void, and we're going to call this light. Just to keep things simple. Remember the brackets, right? So we're going to space it out a little bit, and we're actually going to steal this code from a loop, and we're going to take it and we're move it down here to light. So we're just going to take the code and move it from one function to the other. And now, this is where the real genius of the situation happens. Now, if you want it to run in loop and run this in loop, all you have to do is call it. The call function, right? Let's put an L there. It doesn't make much sense otherwise. Use the curved brackets with a semicolon, and now just upload it again. Now you have removed the brunt of your code to a remote function, and now you're calling it in your main function, and as you can see, it's still blinking with no errors. Off to a great start, right? Now, here comes the part that I really like. I think is probably brilliant, really. You can actually name variables inside of it. Okay, we don't want to call it int because we don't do that there. That's where we're going to put the information we're going to pass forward. And then what we'll do down here in this void, this function, we're going to put the int there because we're going to name the value there, and we're going to call it hold. Okay, and as you can see, that's going to pass down a number. So we gave the function a variable, and what's that going to do is it's going to take that variable with that function down here, and it's actually passing this into this. And now everything that's down here can see it. Right now nothing can use it because nothing's named hold. But what we'll do is we're going to put hold here, and we're going to do it again down here on this delay as well. And now, just by changing this variable here, you will change how the delays work. So let's upload it again. We read our verbose, and now we're off. See, now it's still blinking. Now, if you want to be like, oh, hey, you know what? Let's make that run faster. Let's put 200 in there and let's upload it again. Now watch what happens. You changed one variable, and all of a sudden, just like that, we're up and going. If you want to slow it down, no problem. Let's put 1,000 in there. 1,000 milliseconds. So that's 1 second, right? So now off goes the verbose. It does uploading, and there we go. Isn't that impressive? That is really cool. And through the rest of this course, through the rest of this mini-series, this is the way we're going to be programming everything, because I feel it's necessary to learn proper technique, proper structure, and this makes complex coding so much easier to use. We can also go do something like this. If you want, we can get rid of these. And you can give it, we'll just call this val for short for value, right? And then we'll put that here, right? So now it's going to pass on whatever it reads there into here. So now what we can do is go like this. And remember from earlier, we have on, and then we can go delay and say, well, we'll do 250. Why not? And then we'll just come down here again, light. And then we'll say off, semicolon to terminate the line, not colon, semicolon, and then we'll give it another delay, 250, right? Now once that's done, it'll work exactly the same way as we have before, but now we're doing it through the use of a function. And there it goes. So through the rest of this I know I just said this, but I'm going to say it one more time. Through the rest of this mini-series, this is the way we're going to start programming everything, because I think this is hugely important. And once we start getting into, we're going to move away from delays here really soon. So we're going to start counting mils or milliseconds, and that's how we're going to start figuring out everything, because it becomes hugely important if you want to start doing multiple things at the same time. Because unfortunately, when you use a delay, it's a blocking code. And what that does is it locks the Arduino up for 250 milliseconds, and it cannot do anything else while it's waiting for that time to elapse. Not really good if you wanted to do multiple things. If you want to use it to move a servo, you want to read a potentiometer, and you want to run a light at the same time, delays are not going to be the way you're going to want to do this. And you will most definitely want to start running in and using mils, because then you'll be able to use that stuff all at the same time. But where am I at with the counter? 11 minutes. So we're going to wrap up this episode. This one a little longer than I thought it was going to. But stay tuned for our next. I think the next episode we're going to dig into. We're gonna reuse this. We're going to reuse this setup with the code we got, and we're going to set up a potentiometer and a button, a tactile button. We're going to set those up, and we're gonna play with those on here. And at the end, we will actually set up this right here, this RGB LED, and I'll show you how to hook it up, how to run it, how to program it, and get all sorts of really cool colors out of this. So, thanks for viewing, and stay tuned.